Hello, welcome to STEMCON at the College of DuPage. The title of this lecture is Politics and Geometry, and it's What is Gerrymandering, Part 1. The Constitution of the United States provides a baseline framework for government representation schemes and voting processes, including a mandatory census every 10 years. Based on the census, the states redraw the boundaries of their congressional and state legislative districts after the census, and the party who is in power draws the boundaries. So what happens is the way districts are drawn can have a big impact on both voters and politicians. It can influence who wins elections, how political power is distributed, which communities are represented, which communities are not well represented, and what laws are passed. So there's a powerful incentive to manipulate these for political gain, and over the past 2 decades, these manipulations have grown increasingly common and sophisticated. As an example, suppose we have 50 precincts. 60% are of the yellow political party and 40% are of the green political party. And these 50 precincts are to be apportioned into 5 districts with 10 precincts in each district. Suppose that the yellow party gets to draw the picture. Well, they may draw it this way, where they draw horizontal lines, and you see that yellow will win all 5 districts. If the Green Party gets to draw, they may draw more irregular shapes, but they can configure things so that the green wins 1, 2, 3 districts, and the yellow wins 2. Now there are multiple ways that we can also have proportionate outcomes. Here, yellow wins 3, green wins 2, and here also a different solution, yellow wins 3 and green wins 2. Note that these solutions aren't unique, and it's not really clear how close to being proportionate you can be and how close you should be. This game began in 1812, where the governor of Massachusetts, Elbridge Gerry, signed a bill where things could redistrict, where there was a single district created shaped like this monster. Now, that was successful because that created a favor for his party, the Democrat-Republican Party. And so they titled this, they took his last name Gerry, and they thought that looked like a salamander, and that became to gerrymander or gerrymandering. Now the following coin sequence is from Bob Millman's award-winning YouTube video. So suppose we have 50 dimes and 50 pennies, and there are going to be 10 representatives chosen. So each district map must contain 10 coins. But people don't live in segregated fashion like this. Let's make it more realistic. So if we shuffle the coins around the table, what we see is that this dime lives in between 2 pennies. So you see you can live very close. And this represents how the precincts might actually be laid out. If the dimes draw the maps, what they can do is they can draw configurations, and you can count to see where the pennies are clustered here and here, so the pennies win 2 of these districts, but you can verify by counting that the dimes win 8 of the districts. And if the pennies draw the maps, the pennies win 8-2, and they get the dimes clustered here, and let's see, over here the dimes are also clustered, and the rest we have the pennies winning. And if you draw more reasonable shapes, and we'll talk about compact shapes, you get a more balanced situation. You have the pennies winning here, 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 and here. They win 4. The dimes win here, here, and here. And 3 are toss-ups, depending on how many people come out to vote and what type of people come out to vote. From what we learned in the first video, it's possible to change election results based on how the votes are grouped. In this activity, you will be the one deciding how to group each district. For each puzzle, 2 copies of the same map are provided. Groups cannot be formed on a diagonal, and white spaces do not count for either blue or red. All spaces should be included in the grouping. There are 33 red spaces and 33 blue spaces on each diagram. Each group must have at least 3 blocks. Your challenge is to group the votes in such a way that the red will win on one diagram and the blue will win on the other diagram. And the diagrams, of course, are identical. Adults are allowed to help youngsters, but you should allow the youngsters to contribute to the solutions in some way. You may print out multiple copies in case you make a mistake. Mistakes are okay. That is how we all learn. So, group the votes in such a way that red wins on the top and blue will win on the bottom. And this one is easier than the second one. This one's a little harder. Red win on the top and blue win on the bottom. Here are some tactics that people use to gerrymander, and these are implemented often in software. Cracking involves spreading voters of a particular type among many districts in order to deny them a sufficiently large voting block in any particular district. Packing is concentrating many voters of one type into a single district to reduce their influence in other districts. Hijacking redraws 2 districts in such a way to force 2 incumbents to run against each other in one district, ensuring one of them will be eliminated. And kidnapping involves moving an incumbent's home address into another district, making it more difficult for them to get re-elected. These tactics are typically combined in some form, creating a few forfeit seats for packed voters of one type in order to secure more seats and greater representation for voters of another type. For the most part, courts have refused to get involved, but they have observed that there is no standard for which to judge it, and some say the standard could not exist. And another judge said he wished a clear and precise standard could exist. The case that they were thinking about here in Pennsylvania involved a red swing from a 9-9 blue tie with red to a 13-5 red example. Other cases in Maryland recently involved a reliably Republican district moved 700,000 voters, produced a Democratic district, and the defeat of a Republican incumbent. And in Wisconsin, the General Assembly was 2/3 Republican members and 1/3 Democrat, even though the aggregate votes were roughly 50-50 for the Republicans and Democrats. Now, some of the attorneys have proposed that a good way to think about this is what's called an efficiency gap. The efficiency gap considers the number of wasted votes cast by each party. So, for example, in a 500-vote election in which Party A wastes 70 votes and Party B wastes 180, the efficiency gap would be 180 minus 70 divided by 500, or 22% in favor of Party A. The plaintiff suggested that an efficiency gap of 7% or more is considered legally significant. And this is not just then. Since March 2021, these are 3 headlines that I grabbed just this morning. It does have to do with communities of color. Here's one from Long Island, and here's one from Texas. And it's much more widespread. Here's a map showing that it is really spread across the entire United States, and I would argue, in fact, across the entire world. Some have proposed measures of geometrical compactness. And this circle is very compact, and this is not compact. And I'll show you the equation in a moment. This is called the Paulsby-Popper test, and it's a mathematical measure of the shape, and it measures the degree of gerrymandering. And this was developed by some attorneys, but the index is the PP index of a district is 4 pi, the area of the district divided by the perimeter of the district squared. And this is 1 if it's a circle, and this little thing that looks like a toilet brush has a measure of 0.08. This is better than this. But these two can be smurfed, and that gives rise to research currently happening at the University of Illinois. And Dr. Cho, a professor of political science, statistics, mathematics, Asian American studies, and law, wow, she is everything, at University of Illinois at Champaign-Urbana, and she is a fellow at the National Center for Supercomputing Applications, uses their computer to analyze vectorial maps. For example, she consulted at an Ohio case recently, and she did an analysis based on more than 3 million simulations of possible maps for Ohio. Now, she creates millions of these map simulations using a Markov chain simulation algorithm that produces an array of map scenarios and can be compared to the current map. And so she advocates using this type of analysis to help judges assess whether partisan considerations are excessive and thus unconstitutional. To summarize for now, there's lots of societal wrongs to right and lots of STEM to help get it done. Maybe next time we'll talk about the Electoral College. Take care.